Our next speaker will be Richard Lamb from Iana, ICANN, talking about Dnssec at Iana.
Okay. Can I just plug this in? Yeah,
Sure.
Sorry, it's just kind of slow. I'm going to use this. I'm going to see if this works. Yeah. Okay. Let's just use premium. This should work. Okay. Well, I got it here too. All right. Yeah, I'll start to get this so that we'll do the dual thing. So let's see well, yeah, that'll only switch right. I'll try to fade right. Okay. Do it.
There you go.
Okay. There you go. All right.
So you're okay?
Yeah. Okay. Sorry, guys. I wish I had a Mac. First time I'm trying to use a dual display on a on PowerPoint here, so I'm just going to give up and wing it. All right. Okay. My name is Rick Lamb. I work at Iana at ICANN, working for the Iana group. And this is a presentation on Dnssec at Iana and some of our efforts there. Some of you have heard our various efforts that we've put into place over the past year, over a year, trying to set up a test bed and other things. But there have been some recent events that I think are worth talking about. So I'm going to start off with some recent events before I talk about my implementation. All right, Dnssec, well, in some ways it's a PKI. It's SSL for DNS without encryption. This slide's mostly for maybe some bureaucrats. Okay, recent events. Well, it started. There were a number of calls from the community starting in 2006 for the root to get signed. So we eventually listened to them. We got some, so there's some press requests as well. There were some TLDs that had been signed for quite some time, and we drew heavily on the experience from many of their deployments. And as you know, .org is announced, .gov is announced, and a lot of these TLDs are getting signed very soon. The signed root makes it a lot easier for some of these deployments to happen, and so there's a lot of drive for that and a lot of requests for us to get moving on this. So, close cooperation with some of the people that had done Dnssec deployments, particularly .se, .uk, Jacob Schleider and Roy Aarons, and just some of these guys completely saved me. I mean, we based our design completely on their trailblazing efforts, so that's a very important aspect. So we developed a signing system. It's been available at nsiana.org. It's public. It's port 53. Go ahead and knock on it. It's also got an HTTPS website that you can look at. It's been there since June of 2007. Working fine. Interesting plots here and there. A little spike around, August 5th. That was kind of cool to see. All right, so we did some presentations since then, IETF Right, and ICANN meetings, OARC, and others. Let's see. This is not just a little side project for us. It's actually in our strategic plan, and there's a budget, and I'm drawing a lot off that budget. So, I mean, it's real. We care about it. So around showing that we care. Around the July 24th, we released a paper just saying, here's what we think. This was not any kind of position paper or anything, but here's what we think about Dnssec at the root and various other aspects. And then, thanks to some folk at RIPE, we were kicked into action to develop something called an interim trust anchor repository. So, if the root doesn't get signed for various political reasons, at least, hey, we already vet records from various TLD operators. That's our job, root zone management. So we might as well take some of the DS records and put them on a website, a machine-readable website with XML and stuff. And so that was an interim trust anchor repository. I keep saying almost there, almost there. I mean, it is almost there, and there's just some details if you want to do this right. Okay, August 5th, we all know. Thanks to Dan, boy, kept a lot of us busy. Let's see. Okay, well then, again, thanks. I think partially thanks to Dan, but thanks to there's this just growing effort, growing pressure from the community to try to get the root signed. So, Department of Commerce was receptive to a proposal. So ICANN submits a proposal to sign the root on September 2nd. We got a response from them on the 9th. You can feel free to look at that. VeriSign submits a proposal, good, on the 22nd to sign the root as well. And to show even further interest by industry as well, not just this little community, but it's important, particularly to politicians, that there's interest from a wider audience, like industry. And so on October 1st, there was actually an industry meeting in DC about Dnssec, which no particular conclusions, but it's good to see. So people are actually getting energized about this, and so it gives me a good warm feeling that maybe something will happen this time. All right, so on the 9th of October, NTI, that's Department of Commerce, a particular office within the Department of Commerce that acts as the technical advisor to OSTP, which works at the White as part of the executive office of the White House. It deals with science issues. Anyway, too much detail, but there's an alphabet soup here. But so they released a 45-day notice of inquiry. So that has begun. Part of my talk here will be is to say, if you got any comments, make them. This will end. The notice of inquiry will end November 24th. This is a technical notice of inquiry. They really look for technical feedback, which is a rare thing, but a very good thing. So this is good. So we've gotten some press too. If you look at that Wired blog, there's some press moving around. So, all right. I'm going to talk a little bit about the notice of inquiry. Oddly enough, you go to the Federal Registry. It's one of the pretty good read. It's pretty accurate. It's fair. I think I have a lot to thank. Probably some folk from NIST and other agencies, as well as DHS, for that technical, clear and accurate technical description of the issue. Once again, I worked in government for a while, so I was pleasantly surprised. This was rare to see this. All right. If you do look at that page, Flow 4 is our proposal. Flow 5 is VeriSign's proposal. And so the only issue that I saw looking at all these things, oddly absent through all the various flow diagrams, was any depiction of the flow of keys between the TLD operators and this system. So, okay, we all worry about the root key and, KSKs and ZSKs for the root, but this really is some sort of, it is a chain of trust. It's a PKI of some sort. So, there was no mention of how, how that portion was, how the keys flow in that particular direction. But other than that, it still was pretty good. All right, so, and they published both VeriSign and ICANN proposals in their entirety. All right, well, just a quick picture. This is one of their pictures. The bright red lines are what I'm trying to say. Well, hey, what happened about these guys? You didn't talk about these guys. So, but you can look at the proposal for that. Okay, 2 proposals to sign the root. And I do work for ICANN, so if this looks, I'm trying to keep this as balanced as possible. But if it looks a little tilted, hit me. So I'm trying to do the right thing here. I mean, I'm looking at this from an engineering point of view. That's my job at ICANN. It's not the policy stuff. So, all right, the ICANN proposal. We just said, okay, what's the best design? What's the best way to do this? No restrictions. And so, we think, well, the guy who vets the information should sign the information. So, that was our main kind of motivation. And also, I've spent so many times trying to write key ceremony documents and key management documents over and over again. They keep changing. This handling the key is something that the community has to decide how to do. If there's going to be any hope or trust in the final system, it's got to be something where the internet community says, yeah, okay, we believe this, we buy this. So we proposed that a task force or a group of experts look into how to do the KSK handling, and we'll implement it, and also to determine who, how, where, what are the roles, who does things. VeriSign's proposal assumes that Iana does not create the zone file, because the current situation is that VeriSign actually creates its own file. So there is this separation of duties, and that's the current situation. So they're just assuming that situation and starting from there. So this would mean Iana vets the keys and transfers the keys to VeriSign. They also have a detailed description based on, I think, a Luna CA HSM using M-event KSK handling and the M-event KSKs we handle with various root server operators. So looking at all this, what we saw this whole root signing thing it's really a question of trust. I mean, there are a number of root zone test beds out there. Anybody can do this. Anybody can generate a key pair. Anybody can generate a KSK. It's really a question of, once you generated that KSK, or once you generated those root keys, or, people have to trust it and use it. If they don't trust it and use it, well, anybody can do this. And it dawned on me, this seemed very much like classic, the cooperative definition of why the internet exists and why it keeps running. I mean, battle I continue to have when I worked in the State Department, trying to just explain to these people, look, if you push too much on it, it's just going to go away, it's going to move. So, it's this cooperative thing. So, with that in mind, some of the issues that I try to emphasize is, the community has to come up and trust in, how the KSKs, how the keys are generated, protected, by whom, how it's published and attested to, which I think are very important things. I mean, you can buy fancy equipment to protect anything and decide who, what, and where, but publishing it is what gives the KSK power. Okay, makes it important, makes it valuable. Okay, and so it's they who control the publishing that and attest to it that in my mind control the value here. And there should be, of course, steady auditing and reporting on this stuff. I mean, this is not a set go and just forget about stuff. In any case, in the end, I mean, whoever's doing the signing can sign the content, can sign whatever content they have. So that's an implicit trust that is just going to be there regardless of how this is done. All right. Well, I'll try to go through this stuff kind of quickly. All right. So it's really part of a chain of trust. It's not just the root key, but there's this chain going down through TLDs, through second-level domains, and we all know how the DNS works. So there's this chain of trust. We should look at this a little bit like a PKI, not just good old DNS in some ways, and try to draw on the experiences and the background and that's already out there for PKI and how that's handled. It's only as trustworthy as the weakest link, of course. There's going to be a lot of pressure on that root link because all the TLDs will be hanging on it. And if this platform, if this is done right, I've started to hear from some people that there are a lot of other things that can be built on this. I mean, okay, so we have SSL and we have CA, so that's one branch that protects the conversations over the internet. But here's something that protects the phone lookup, telephone number lookup, but it also gives you this chain of trust that if it's done really, if done correctly, we could. Well, people have said DKIM, but I also heard OpenSSH as being something that would be something that could build on that trust. I think there'd be a lot of products that come out of this thing in the long run. All right, well, this is my attempt at some art. Okay, so I went to the boat store, bought some chains and some locks. So and so here's the Dnssec the chain of trust. There's a root trust anchor at the top. Okay, I'm thinking whoever vet should sign. So there's one link there. TLD's next link down. Second level domains. There's a lot of pressure on that central link. Okay. So add an extra link to the chain. Well, it's definitely not pretty, and my intention here is to show that, well, this adds a little more complexity and another avenue for compromise into the chain of trust, and also another security regime. Okay, so I don't know how well that little gold lock shows up there, but there's a lock there for the link. So, okay, so we vet the information, we send it to somebody to sign, it's going to go over some link. Of course it's going to be encrypted, but who controls the keys of that link? I mean, even SCP or whatever we all use, still there's a public-private key pair, and there's things that we need to be aware of. I mean, whether that's with a smart card or just a file, .ssh authorized keys or whatever. There's something that has to be. There's another security regime there that has to be taken into account, and so I think this weakens the link, weakens the chain. So, all right, key questions. It's all a balance. It's a careful balance of control, security, stability. One might say, okay, we don't trust anybody. All right, we want to be there for every signing, anytime anything is signed, anytime anything is used. Well, okay, that becomes you got great control there. Okay, so you could have 50 people or whatever number of people that feel that they are stakeholders in this process. That could be a very large number, want to be there to control this. Fine, give them M&M control, whatever you want to do. And, and if that's what, I have no vote here, okay? So if that's what everyone wants, that's great. But then you end up with stability problems. I mean, what if M guys can't get together in time, or even if it's done remotely, if this doesn't happen? In Dnssec, if people start relying on Dnssec, if a signature expires, you get serve fail. So, you fail. It's not like, okay, you get an unsigned response. Okay, maybe in the future specs will change, but that's not currently the behavior. So it's very important from a reliability point of view that this keeps going. Anyway, so that's one example of one of these balances. Compromise recovery. A couple points down there. That's again a different issue with how often do you want to assign the ZSKs? How often do you want to generate ZSKs? Are you worried that the ZSKs can get compromised easily? Then you'd like to generate them more frequently. I mention that because again, I get all my information from people who actually do this stuff, the Dnssec deployment for a living, and that's one point that has been considered. So that's something where you'd have to then have the KSK be able to automatically or in a very easy fashion without getting a quorum of people in a room to get that to re-sign new ZSKs very frequently. This could be weekly basis, monthly basis, what have you. But again, if any part of this doesn't happen, it fails. Okay, the lookup's going to fail. So, and other questions about backup and backup sites. In our proposal, or one of our proposals, it's the idea of backup is anytime you have a backup of something, now you got to protect the backup, and then how you split the control of that backup, it just gets to be kind of difficult. So why not just make, when you generate the KSKs, why don't you just generate them in 10 boxes or 12 boxes, and then there's no backup. They're pre-generated. Okay, so that could solve that problem. That's one example, but that may not work for everyone. Like I said earlier, large participation. Want to get as much trust in this, invested in this as possible, so you want as many people involved. But how do you get them involved without necessarily giving them all one bit of the key or something else? I mean, and I think that's where things like key ceremonies, it's not my term, it's a standard term used in certificate authorities, but where a key ceremony where everyone is there to witness and attest to keys being generated in some sort of device that everyone can test and has been audited is a good thing. So in the end, and this is flexibility is important. I mean, whatever design, whatever we end up doing to sign the root, and whoever does it, it's got to be a flexible process. It's got to be something that can be changed as we learn more stuff, because we do continue to learn stuff about Dnssec deployment. So that's kind of important. It's too small font, forget it. Okay. All right, so some basic elements of the root signing. I don't want to drone on too much here, but important elements. It's got to be transparency, public consultation, broad participation, flexibility, reliability, trust. got to balance all the various concerns. Should be the most secure, particularly from a technical point of view. It should be the most secure technical solution we can come up with, and then anything else, is a compromise, and should be should allow us to build on the trust in Dnssec for other things as well. Okay, last bullet probably is an IGF bullet. Okay. All right. Preservation of trust. Again, maintain the trust we have from TLD operator. Right now, we vet information with the TLD operator. There's need-space relationships. There's technical checks on this. There's a lot of relationship building there between CCTLD operators as well as TLD operators, and it's currently something that the Iana function does, and it is part of the Iana function. So we'd like to preserve that trust as far as we can. More use of DNS or Dnssec, more people depend on this chain. Okay, yeah, stop avenues of corruption. Yeah, those are things that I'm not going to read them out. Those are things you can read just as well yourself. There is the introduction of new GTLDs, something that's kind of an aside to this, but that will increase the number of things in the root zone and really stress this whole operation as well. Right now we do like about a change a day. So, if you envision that going to, I don't know, it's 300 zones, goes to 3,000 zones, or, talking about 10 changes a day, that could get actually kind of difficult. So it's something to keep in mind. Transparency, okay. That's our mantra. That's our whole process. I mean, at least with the Dnssec effort, that as long as I've been involved, every single design I've had and thought I've had, I present at some conference somewhere, whether you guys want to hear it or not, and describe the, down to the IP addresses and how it all works. And so I think it's important to continue doing that. It's important. Whatever we do, we will keep, of course, open source. There's no business angle for us to keep anything proprietary. KSK should not be the control under any one organization. And then continued collaboration, through the IETF and through forums like this to continue to make sure that we're doing the right thing. Okay, so it's our business. We've been doing it for root zone management. It is our business. We've been doing it for a while. Dnssec is part of it. We've had this test site up for 15 months. It just replaces the root zone. If you want, if you go there, there's a sample hints file. And we have something called Root Zone Manager, which is a whole other side of Iana that's being developed that should automate some of the processing of these updates to TLD things. Not completely automated, of course. There's always going to be that need space element, but that's a two-factor thing and designed properly. But it would handle BS records as well. And so, okay, a little detail, but the ITAR, the Interim Trust Anchor repository that we'll have up will give us an opportunity to get some experience here and on how to collect this information and what kind of questions to ask people when they're submitting that information. We've kept our design really simple. It's been the goal all along. Dnssec deployment is difficult enough as it is. Managing keys is difficult enough as it is. This has really got to be simple, particularly if it's going to be inspected and under the scrutiny of the public. Let's see. Okay, let me describe those. All right. I can go a little bit in the key. This is just one example of a key ceremony. There wouldn't be any control in any one organization. In our proposal, of course, we would be using the KSK to sign things, so we would be the custodian. But we couldn't generate one, we couldn't change one, and if we did, it didn't matter anyway, because only the one that that's published and tested to is going to have any value and going to be distributed in whatever way, Windows Update or what have you. It's going to be distributed in whatever way it's going to happen. In part of this design is to generate use fresh hardware every time. That may sound kind of wasteful, but if it's important enough, we don't have a problem with that. So, buy a new, $17,000 HSM a year, and generate 2 keys in it. That's fine. There are people that actually do stuff like that. So, for other purposes. So, but that way there's no cards to control that have any of the contents of the unit. There's no way to tamper. If you tamper with the unit, it just deletes things. There's no reusing of the unit. It's always fresh. It's a new lock every time you put it up there. Anyway, but in the end, the community has to decide how all this is going to happen. These are just my efforts there. As I have to do something to earn my living here. Let's see. All right. Well, what we use now is a FIPS 140 level 4 box HSM. That's the highest level you can get. And level 3 is if you tamper with it, it says it's been tampered with. Level 4 just deletes everything. And there are very few of these things. You know, maybe 2 or 3 companies that sell level 4 boxes. And so we got one of these things. It's used by UN treaty organizations, MasterCard, a few other companies as well, military as well. So it's a pretty stable unit. Private key never leveraged these box. I said that earlier. We would back up the HSMs back up the key into multiple HSMs, and this all works off of something called PKCS11, and something I spent a lot of time writing drivers for to make sure that we could switch from different vendors. And you know, these things might be around for 10 years. I mean, you look at some of the CEA authority keys in your browser, and they're good for 20 years and more. So. Who knows if that vendor's still going to be around? So it's got to be based on a standard. All right, so now to some of the meat, okay? Behind NSIana.org. I don't know how clear that is. I'm clearly not a graphic artist, but that's kind of what we have now. Yeah, that's what we have now. And it has IP addresses on there for the 2 hidden masters. Thanks to PCH, we have an Anycast that's been operating for some time. The IP address of that is there as well. Feel free to bang on this as hard as you want. It would be great. The whole idea here is to, get as much testing and as much testing as possible and experience as possible on this. It's envisioned. There's some grayed out or blued out boxes there. It's envisioned that the actual, if we end up doing well, in either case, it's probably going to be like this. But if we end up doing the signing of the root, we would put a root zone database right there inside there in the same container physically as the signing equipment, and access to that would only be through a local connection and controlled access to the database, basically, depending on identity. And the whole unit, all the equipment in the box there is slated to go on a Class 5 GSA safe. This is like one of these things certified to top secret and all. It weighs about 2,000 pounds. It's having a little bit of difficulty finding a colo or a place able to hand that sort of weight. But that's the goal. We've ordered it. We're just waiting for delivery and putting that in place. And again, some of this is there. We just want to be very careful about this. We're using the highest quality HSMs we can, the best kind of containers we can, because this should also look secure as well. I mean, some of this is optics. I mean, I'll have to admit, but it has to it has to not only be secure but look secure. And so it's important to go through this type of stuff. I was speaking to somebody who is an expert in some crypto matters, and they said that the whole security picture is 3/4 black art and 1/4 real engineering. So any of you versed in the black art, I certainly would like to talk to you afterwards to know if what we're doing is right, or even if it makes sense. Even if we don't end up signing the root either way, and we have other zones we have to sign. I have in this picture. The IAB had asked us some time ago, embarrassingly some time ago, and we're still waiting for some politics to shake out. .arpa, inatter.arpa, ip6.arpa, iris.arpa, urn.arpa, uri.arpa, int, maybe they didn't ask us to int, but we're signing int because that's also under our control. And so if you use NSIana.org, the list of domain names that are off there to the side are ones that you will see keys for. Let's see. It's a couple minutes. Oh, is it? Okay, all right, you're. All right, so this I'll make really quick then. Design goals, the idea is make this maintainability was key. That was they were my marching orders when I first started working there. And I've learned now from others who have done some Dnssec deployments, this has got to be as automated as possible. Reliability, as again I said, signature expires, things fail. So that can't happen. Must look and be secure, preserve the trust. Let's see, I've broken it down to basically 2 scripts, one that does signing, one that does key generation. Actually doesn't generate key, pulls off of some pre-generated keys, but can't generate keys, but keep it simple again, 2 scripts. This is completely taken from .SE's design because they were at the time the only ones with any production experience, so go for it, just follow their lead. So 3 ZSKs, 2 KSKs, all overlapping. This makes it really easy to roll things over and insert new things. Something that people don't talk about a lot, I actually wrote a script to replace keys. So if you see a bad key or compromised key, I mean, that sometimes is a very manual process. It doesn't have to be or should be assisted a little bit. So I have something called bad key. As you saw in the earlier picture, there are 2 signers. They're doubles of everything. One fails, the other one picks up. We have not picked a backup site yet, but we will for a number of other reasons as well. The redundant hardware, we use Dell 1950s now with double everything. Let's talk some more about the HSM. I already covered that. Everything's done inside the HSM, if you guys are familiar with those. I mean, that's their function. Key lifetimes, what we've chosen for the test bed is those are the key sizes and key lifetimes once a month. A new ZSK once a year, a new KSK is brought in. Those are the bit links. We can handle up to 4096. Let's see. All going to be open source software. There's some of the piece of software. I don't know how well you can see that, but just to show that we are working on interim trust anchor repository, there's a screenshot. There's a screenshot of the status page for our testbed. And kind of the main point here is there's this notice of inquiry. We got to a little before Thanksgiving. It would be great to have whatever comments people have in there into the Department of Commerce's hands by that time, because it's your route. I mean, if you want the route signed, I know some people may not, but if you want the route signed, I mean, this is your opportunity to help us do the right thing, and keep your foot to the gas if you want this to keep happening. I certainly wasn't alone. That's not even half the list of people I need to thank. I mean, there are an awful lot of people. I haven't been working on Dnssec like some of you have for decades. So all these people helped me bring up the speeds. Some security experts down there toward the end that deal with kind of the black art stuff too. Very helpful. Very, very open. So that's it. Any questions? Wow. That was easy. All right. Okay. Thank you. All right.
Okay, we're now going to have a break for about a half an hour. So back here at 11:30. And
just a quick reminder. Yeah, the elections are, so far none of you all have voted. We checked and you haven't voted. Please vote. This is seriously, the rate of turnout is even more depressing than in US presidential elections. It's really bad, folks, so please do vote.
I was thinking about it.
We just started doing. So I gotta board meeting.
On the program committee between now and lunchtime, we have 3 presentations, 2 on IPv6 transition issues, another on security. I don't think that the first speaker needs much introduction. I'm sure you're all very familiar with John Curran and his ARIN and server vault roles. He tells me he's speaking in a personal capacity today, so I will hand you over to John.
Thank you. Okay, good morning, everyone. This is pretty simple stuff. It's not rocket science. I'm going to talk about an RFC. It's an now a informational RFC. This is an individual publication. I wrote this and had it published by the IETF. You can actually do that. The IETF will publish things outside of a working group, entirely to try to talk about coordination of this upcoming transition for IPv6. Here's the problem statement. We have the entire world trying to figure out how to move to V6. And everyone's got their own timeline. Everyone's got their own schedule. And there's no standard way of communicating how ready you are. And there's a great probability of mismatched expectations. You're thinking V6 is pilot, and someone calls up and says, hey, how come this website's down? Or how come this route is down? The problem here is that this doesn't bode well for us. It doesn't show particularly well to the international community. You run into folks like regulators and government leaders who ask the question, what's the plan? Okay? And rightfully so, if you think about what's riding on the internet. We've got the economy, a big piece of the global economy riding on the internet, and people in public policy positions want to know there's a plan, right? We're not just making it up as we go. Well, the problem is there isn't a plan. There's also no body that can create a plan. There's no one with the authority to call the question and say, okay, this is the official plan. And I thought about that for a while, and I thought, this is a really bad situation, because policy folks and governments and regulators, in the absence of a plan and the organization, will fill one in themselves. They'll make one up for you. So what I've created is effectively a default plan, which says, if you don't tell the world what your transition plan is, don't be surprised if the world says, well, maybe you're following this RFC. Now, you can communicate your own transition plan, you run your own organizations, but in the absence of anything else, it's really convenient to point to a default set of conditions that might occur during this transition. So I authored this, threw it into the IETF, where it's a little bit of a hot potato, obviously, because the IETF recognizes it wasn't in a position to call the question, but they're more than willing to publish things with a clear disclaimer that says, hey, we just published this, it's not our work, it's not any IETF work. So this officially has no status whatsoever. It's just a document. I sort of said this. No one has the ability to establish a global schedule. But we kind of know there is one, folks. We really do. There's a few people in the room who are saying, I'm going to skip IPv6 altogether. If you're one of those people right now, I got good news. You can continue your break outside. Okay, there's coffee, there's still cookies. Take a walk, have fun. For the next 10 minutes, I'm not going to say anything relevant to you. But if you do believe we're actually going to transition to v6, then yeah, there is a timeline for it. The timeline is kind of automatic. It's based on your favorite depletion curves. You can go find them. Mr. Houston is around here somewhere. His website's one. Though there's actually some other cool websites that let you change your assumptions and do your own calculations. So we know this is going to happen. Depending on what you read now, the RIRs are not going to be in a position to give IPv4 blocks out to ISPs somewhere in the next 18 to 36 months, depending on what set of assumptions you use and what region you're in and a whole bunch of other things. In 18 months, you have a good chance of going to an RIR and saying, I need my next block, and having them say, don't have any. So whether we like it or not, that sort of sets some timeline here. So here's what I put together. I said, look, we're going to have a three-phase approach. Right now, there are some people who think IPv6 is production. I'm not sure I consider it production right now because I can call up a lot of internet NOCs and say, hey, I need help with this, and they say, I'm sorry. Yeah, there's two guys who know v6, and I think they're out at NANOG this week, and you can't even get a ticket open. There's no way to report a v6 problem. The team that's running it has no tools to do the job. So I'm not sure I believe we're really production. So we're in a preparation phase. We're going to be in a transition phase, which is the really cool one, guys. This is where some people are moving and some aren't, and the expectations are variable between parties. That's a really interesting state. And then there's post-transition, where, folks, if you're announcing a v6 route or if you have a quad A, you really got to support it. I mean, we have to at some point get to the point where commercial traffic can be supported in production and really has to be considered that. So those are the expectations that are going to change over time. It's completely voluntary. You can set your own schedule. You say, John, I don't like your schedule. Your schedule's too soon, too late, too soon. We have to get this done earlier. We can't possibly get it done in time. Great. Why don't you tell people, your peers, why don't you tell your customers what your timeline is? But if you don't publish a plan, do not be surprised if someone asks you, are you following an RC 5211 plan? Because there's going to be people, there's going to be regulators, there's going to be folks who approve licenses for telecommunication carriers. I know there's going to be some people who are involved in things like taxation and regulation who are going to say, hey, I think you must be following that plan. So to the extent that you're an ISP and you don't have a communicated schedule, please don't be surprised with the fact that we're looking pretty good because we are saying there's a default plan, and it means that we don't look as disorganized as an internet community as we might. It's completely voluntary. Again, you set your own schedule. Let's talk about the preparation phase. And I think we're here now, folks. I think we really are. It would be nice if you note the IETF should, must, may language. I think it's BCP 9, though Mr. Bradner will correct me. I'm using terms like should, must, and may to say in order to be compliant with this draft, not because you have to do it, but you want to be compliant, you have to do it. Service providers should offer pilot IPv6 internet service to their internet customers. Organizations should arrange for IPv6-based internet connectivity for internet-facing servers, web, email, and DNS. If you've got public servers in this phase, it would be nice to get them connected by a v6. The reason that's kind of important is that at some point, someone's going to get connected and they're going to be accessing you through some dynamic translation box, and to the extent that your traffic is v6 to your website, it'll be native, and to the extent that your website's v4, you're going to be occupying state in someone's translation device somewhere. The more of the internet that we get the most visible public sites connected via v6, the easier this whole thing is. You may provide IPv6 connectivity to internal user communities. I've had people say, I may never transition internally. Yeah, what does it matter? This is talking about intranet expectations. This isn't talking about your private network. This is not talking about what's behind your firewall, because quite frankly, that's your business too. This is getting your expectations lined up with other parties as part of the internet. Transition. we're going to get to a state where it's going to be pretty important to offer V6 connectivity. And you're going to have V6 connectivity because if you don't enter a phase where you have V6 connectivity, translation boxes may not work forever. They just may not. Even with wonderful dynamic NAT and all the various algorithms and all the nice things that people are working on to let V4 hosts try to talk to V6, that doesn't scale. And so at some point, we're going to have to treat V6 as production. Internet-facing servers are going to have to be treated as production. You're going to have to receive a call. You're going to have your NOC be able to open a ticket. It would be nice if you provided internal connectivity. Why? Because your users may start accessing resources which may only show up on V6. And if you don't offer V6 internally eventually, that'll be a problem. Post-transition. We're going to get to the state where the internet is considered to be more V6 than V4. No one knows when this situation is. If you believe that we can extend V4's lifetime a little while, and we can make translations work, and we can do a bunch of dynamic NAT, this could be 10 years before this happens. If you don't believe in those circumstances, this may have to happen a lot sooner in order for us to have full connectivity. Not rocket science. Let's talk about timelines. This draft has some dates. It says we're in preparation phase till January 2010. That was a long time, actually, when I first started writing this. It's now conveniently right around the corner. It's about 15 months away. And that means you've got 15 months, you probably should get your mail and web servers at least connected via V6. That decreases the load on everyone else. It is being a good internet citizen. Transition, January 2010 to December 2011. In that time period, you may have people asking whether you support V6. You may have people expecting, if you do have V6 records, Quad A, if you do have V6 routes, for you to treat them as production. So either pull them out or treat them appropriately. Don't be surprised if we get to a point where someone tries to connect the customer to the internet in a few years from now with only V6 and yells at you because you're not announcing your resources, your website, your DNS, your customer services via V6. That's a post-transition world. There's some other comments in the RFC about use of transition versus native V6. Obviously, we can't run this whole thing with transition mechanisms. You've got to eventually offer V6 services to people via native V6 and not via tunnels and not via dynamic NAT and a few other things. Because it's a short talk, I'll say grab the RFC. Questions? I'm up here once, guys. We got a lot of talks, but if you're going to ask a question, now's the time. Oh, look. Mr. Dan Golding.
Hi, John.
Hi.
Are you sure you want to claim that regulators and tax authorities are going to come down on people if they do not have a transition plan that is compliant with an IETF RFC, a document with no standing in law at all?
Right. So, for example, the Organization of Economic Cooperative Development, the OECD, 41 democracies around the globe, actually had a meeting and they said, we need to have a plan for transition of the internet. And I found out after the fact that, wow, there's a reference to this RFC in the middle of that document, okay? So I'm not saying it's something that is inevitable to happen. What I'm saying is, if we don't show up with a plan, they will make one, and it's good of us to say there's a default, if nothing else.
I just want to point out the U.S. government had an IPv6 transition drop dead date by this year.
Right.
Of course, that didn't happen either. So while the transition is obviously something we want to work for, and your dates are, I think, very accurate, I think one of the reasons IPv6 transition has been slow is because people have cried wolf so many times over the past 5 years that you have to do it now, and now cynicism has creeped in. So I just think we need to be careful.
Just to be clear, Dan, the OMB 2.5 years ago mandated that by June 30th, all federal agencies would transition one IPv6 packet from within their network to something outside their network. It was done to make sure that all the federal agencies bought equipment that had an IPv6 checkbox. Every agency passed the test. It was actually a huge success, so that we don't have federal agencies a couple of years from now being told to turn on V6 and not having the right equipment. So actually, I like your example, but I call it a success, not a failure.
Well, we can take that offline. It was interpreted to mean that eventually, but we both know when the original announcement was made, the original announcement was that there would be a complete transition by this year, and then there was massive, massive backpedaling.
I was sitting in a House panel when the announcement was made with Karen Evans of OMB beside my shoulder. I might see it differently than you.
That's fine.
Next.
Kevin
Yes.
Overman, YesNet. I was one of the people who was responsible for giving feedback to the OMB on this announcement. And I can assure you that from OMB's perspective and from those reviewing it, it was never, ever looked upon as an IPv6 transition deadline for the
Right.
federal government. The press seemed to pick it up as one. I was rather stunned when they did that because I went and read the document again. It never said that. It never implied that. It did exactly what the document said. I do believe many people, shall we say, shortcutted things to meet the requirement. I would not call it a 100% success, but it was reasonably close to successful.
Thank you. Okay, Randy.
Randy Bush, IIJ. I was sitting right next to God when she said it was IPv8, and you can touch me afterwards. But look, boys and girls, we're running out of IPv4 space. Get real.
Right. That's it. Any other questions? Thank you for having me.
Okay, thank you, John. Okay, so next speakers are Anton Capella and Alex Pilotov. Do we have them in the room?
This has been updated in the last few minutes. So Alex could not make it. He had some last-minute commitments in New York. He wishes he could be here. So I'll do the talking instead. So I thought. Okay, so the title is perhaps a bit deceptive in itself. There's nothing being stolen more than any other location that would experience a subprefix hijack that has anything stolen. The interesting stuff here is going to be talking about more interception. So if I could have retitled the slide and got it to the presenter laptop in time, you would have seen something a bit different. So I'm going to go through a few simple points first before getting into the meat of it, and I'm going to assume that everyone understands basic stuff about BGP and has familiarity with the concept of a subprefix hijack. We're not talking about the details of that. We're talking about the implications of in the interception potentials. So first, we're going to talk about a few points and people who have talked about this and a lot of theory that has been spun, and then talk a little bit about the actual application mechanics of this particular operation, and then talk about a bit of what we can do to stop it, perhaps ask for more support from the community to continue to push the further development, and then a little bit of an analysis of what we did at DEF CON. And I think that's probably the more interesting piece that folks have requested in this talk. So ultimately, if you hadn't heard yet, this is perhaps a bigger deal than other types of subprefix hijacks, in the sense that essentially in a blind scenario with no coordination at either the attacker's network necessarily, or definitely the attackee's network, you can attract traffic and bring it right back to that network. And that's, that in itself is not terribly novel, but in the mechanism we'll describe, nothing had been demonstrated to our knowledge of a similar form. The other important point is that to solve these issues requires direct attention. Any providers who are doing adequate filtering now, they're not interesting to this, but the people who are not, and the people who do not have adequate alarming systems in place or interest in generating them are going to be the ones that ultimately help allow the riffraff in, if you will. So prior work, important to cover. So the NIST report from last year essentially just states quite generically, yes, it can be done. We can intercept traffic somehow. No one could say how. The most recent discovery I had made was of a particular paper from Paul Francis at Cornell, and he was using a mechanism that essentially pretended to be, or it would have rather been appropriate to do at a tier 2 type network, somebody with several hundred edges. And his paper essentially says that if you swim through AS path alone and do not do subprefix hijacking, you can actually do that successfully, and then also how much edge capacity would you need, or rather how many edges would be required to net significant amounts of traffic. So interesting approach, but not necessarily like this. The next most near match to this kind of a topic was one from UIUC, and this one was discussing essentially by positioning oneself or finding a network that is ideally positioned, what could be done using essentially traffic engineering techniques to both intercept the traffic and re-deliver it to the intended destination. So interestingly, none of these discussed creation of a path, what we will call in this presentation to be a feasible path back to the target. Again, we're not talking about, and I don't want to discuss the particulars. I mean, getting a route out there is plain and simple. IRR updates aren't secured. There's a lack of trust from the top down. We all know that. The interesting stuff here is that we can create these selective black holes through typical techniques we've all been aware of, and facilitate some interesting interception potential at a large scale, and from essentially any location to any location. The other points we'll discuss, and the other thing that's perhaps half novel, partially novel about this, is that by applying TTL additions to packets in flight, the entire topology, the layer 3 topology, the data plane topology, is effectively invisible to points that are trying to probe perhaps traceroute and tools like that. As far as hiding the hijacker, if the origin route contains an AS path naming ASs of known monitoring ASNs, and if those said monitoring ASNs are employing standard BGP path logic, they would not accept these routes with AS paths that name them because of loop detection as well. So if we knew of the dozen or handful sites that were monitoring and setting alarms, they perhaps would be forwarded through this technique by including them in the path. We'll talk a bit more about how that might be applicable. So what is the concept at large? What is really happening? So to successfully intercept data, you have to both bring it in and then, again, pass it back somewhere. And the interest here is in getting it back and then not breaking things. So we have to create this path. The question is how. And the papers discussed prior had techniques for this, and some of them were, shall we say, non-trivial. There was work required or coordination required. This one doesn't require that. So how do you create this path back? Well, first, figure out what the path from you, the in-place forwarding path from your network, from the attacker's vantage point, towards a particular target is. Do you forward through any particular upstreams? If so, of course you do. If so, then track what they are. If you forward to upstream A, then to B, then to C, note this. You're going to need to maintain that. And I'll diagram that in a short moment. Again, the ASNs are what we need to know about. If you transit through Sprint to perhaps peer of Sprint to the end user, those are going to be the ASs that we have to eventually black hole to use as our return path. So essentially the point is the in-place, right now, forwarding characteristics must be maintained or else you don't have deterministic result. So in the hijacking then, the application of the AS path prepends must include this set of ASNs that you already see back to the target. And again, these are going to be the maintained in-place forwarding elements. Now, once the traffic is arriving, once the hijacked route has been sent, we need to then take the packets that have been received for that particular target prefix, and again, shoot them down this feasible path So a U-turn, if you will, a hairpin, has to occur in our attacker's ASN. And then after we do all that, we go upstairs. So how does this look normally? Let's watch a route propagate from the target ASN 200. They're going to originate a /22. And we see that route propagate, layer by layer, degree by degree. Eventually the attacker hears that route and says, aha, they have a 22. The forwarding table that would be resulting from this would look as such. Now, the interesting thing you have to maintain here is, the path we've currently selected. You want to continue to use 10 and 20 to reach 200. So if this 22 was going to be subject to a subprefix hijack, say a 24, we would have observed that viable path and continued to want to use it. We would then build an AS path list, or rather a prepend rather, to attach to this /24. And so when that 24 is announced, perhaps the font's too small to see, it would be appending to the right of 100, 10, 20, and 200. So what this would effectively do is prevent AS20 from learning that route via 30 or anybody else they're adjacent to, and also prevents 10 from learning it from us. You can kind of let 30 and 40 in your minds represent the other 30,000 some ASNs out there. 10 and 20 could be neighbored up to every single one, and if their AS number again is in the path, that's going to fail checks unless they've disabled that check. So we announce route, said route goes out, and the forwarding path that we now observe, the forwarding table we now observe in all the coordinated routers is what we desired. We wanted 30 and wanted 40 and wanted the rest of the internet to send traffic for that 20 forward. Again, longer prefix already won that to us. But now because 10 and 20 have not accepted our route, all they have in place in 10 and 20 is our /22, as learned from 200. Therefore, they continue to forward this back to 200. And this is the essence of the BGP man in the middle. This perhaps was the part that was not well represented by previous reports and news articles and things online. So again, the traffic can U-turn through us, and we don't break things. We miss, of course, traffic from 10 and 20. So if those were exceptionally large ASs, or customers of those who weren't singly homed, or rather who were singly homed, we wouldn't get that traffic. The attacker in ASN 100 would only see traffic minus the feasible path back to the target ASN 200 here. So once the traffic gets to us, of course, to facilitate the U-turn, toss a static route in. So at DEF CON, as a small summary, the timestamp in epic seconds at the start of the hijack was 252 ASs reporting the /22 at the conferences network. And within 80 seconds, 94% of them carried the hijack 24. And the difference, could be a policy issue, could be customers who were somehow singly homed or somehow not getting the hijacked route from a feasible path that we had used. Not sure. Interestingly enough, it was somewhat successful in this particular metric. Everyone likes graphs. I like academics too, so I decided to get one of the time series. This one will show on the right x-axis the number of ASs reporting having heard the 24 at a certain timestamp. The delta from origin first heard, rather from the first heard announcement, is in seconds across the bottom, and the leftmost axis is the accumulation on the green line of ASs that have been ASs that would have been heard, percentage of total that would have been taking the route, and you can kind of see evidence of MRAI having done its job. So again, when the route's announced, it's fairly quick. We all know that, but if you're near the core, you can insert the hijack route quickly, and it doesn't disrupt things. Again, as the route propagates from the point of view of the attacker, everyone's forwarding to you as each degree transfers the route successively. So essentially, the attacker can insert themselves into the inbound path of a particular prefix and not disturb anything, which is unexpected in my mind. You definitely will see, and we did observe at DEF CON, that when the route was removed or withdrawn, micro loops would cause momentary outages for the next number of minutes until things converged back towards the original origin. So essentially that method then means we have, I think, yet one more reason than just observing outages like YouTube last February, to look and to re-examine ways to solve or ways to perhaps pin trust on the apparent origin of a particular prefix. And I think ultimately this means we need to step it up. We haven't done this in 10 years. I don't want to get up here in the next 10 and still see similar issues. I'd like to have this solved. I guess, of course, we heard a discussion about securing the root prior, and I'd like to hear something similar, more about securing things from the point of view of RIRs. So perhaps the half novel portion will be interesting to talk about. The way that we did this at DEF CON was of course to attract the traffic, but that wasn't cool enough because it reveals a long trace route without doing anything about it. So essentially, Alex's network originated this last 24, and from the point of view of a router on a Chicago transit link to AT&T was taking a detour, of course, into Savvis, then to New York, then to Pilosoft, and then the static route back out was through N-layer towards Limelight and towards then Switchcom. By adding values to TTL upon ingress, you can then effectively hide all of that. And this is a trivial thing with IP tables. It's an increment command. Add some number to it. All of a sudden, trace routes don't reveal you. So with an adjustment, the hijacked route is 13 hops. You could have made that arbitrarily short. Could have been 10, whatever. Could have hidden all of the ingress paths to Switchcom group. But again, the original went from AT&T to Limelight. The hijack now goes from AT&T to Savvis to Switchcom. And there are no observed edges anywhere on the internet between Savvis and Switchcom, behind Savvis that is, but to anyone doing a trace route, this isn't obvious. You'd have to have a view somewhere. Ideally, someone looking at things to secure things would do more than just look for subprefix hijacks or subprefix origin changes, but also something that would look at perhaps a tomography or a topology approach to pinning down the intersection of does that edge that we see or we elicit really exist in routing. Could be open to a lot of interesting, perhaps, research. So the default way to originate a prefix, of course, would reveal your, or rather the attacker's origin AS in the path. A friend had turned me on to the point that devices that support transparent AS, or rather software daemons such as OpenBGPD, Quagga, can send routes with any apparent origin AS. And if your neighbor's not enforcing next AS, on the neighbor session, they'll accept this prefix, they'll accept this advertisement without any troubles. So perhaps the attacker could even be completely opaque in the origin of this subprefix. If you had perhaps a session to your transit configured as reflector client or route server client, as you might add, say, an MPLA style route server based exchange. So this opens up yet one more avenue for being somewhat stealth. Again, this will not make any sense from what a real relationship would reveal if you could examine the actual data plane at each particular adjacency. And again, this could be an avenue for detection as well. So, shorter talk than perhaps we had planned. I think we have time for some questions, certainly. But I guess all I wanted to summarize by saying was that this is pretty stealth, can be nearly invisible, yet you'll still see some disturbances from the point of view of a subprefix hijack. If we consider some of the papers, especially the one from Cornell, we know that we don't even need to win with subprefixes. If a certain network were co-opted, this could be done without subprefix hijacks required. Subprefix wouldn't even matter. We would just win through edges. And if you won the right edges for whatever the purpose was, then the need is served. We know that, again, path isn't going to be the only telltale, but it could be massaged. So we can't depend on that alone to perhaps detect it. So I think this points to a combination of mechanisms required to adequately protect this or alarm on it. And bottom line, filter your customers, turn on NextAS, it's on an iOS by default. It's probably good to turn it on if it's not older software. And that's all. Any questions? Ivan, Randy? All right, thanks, guys.
Thanks, Tony. Okay, we're back to IPv6 again. And we have Hakon Ringberg from Princeton talking on some work he's done with Danny McPherson.
Hi everyone, I'm Håkon Ringberg. I'm a PhD student at Princeton University, where I work with Jennifer Rexford. This work is not with Jennifer Rexford, though. It's work I did while I was an intern at Arbor Networks this past summer. And my collaborators are listed on the slide, Craig, Danny, and Scott. So as the title suggests, this is yet another IPv6 talk. I'm sure you're thrilled. We, however, looked at traffic data, and I think a lot of people up until this point have had only indirect estimates of the amount of IPv6 traffic on the internet. So I hope first to put this talk into a bigger context from Arbor's perspective, a bigger measurement push that Arbor is going through right now. Then I will talk about why you might care. I'll repeat why you might care about an IPv6 measurement talk, introduce our methodology, the key results, and then to preempt some possible objections. We got some feedback, mostly very positive, but some complaints with the methodology. So I'll go over some potential weaknesses with the methodology. So if you're itching when I present the methodology to complain, you're of course welcome to scream at me, but I might cover it later. So like I said, what we wanted to do is provide a global and longitudinal perspective on the amount of IPv6 traffic that we observed in the internet. And this really is part of a bigger push at Arbor to leverage their deployments, the probes that they have in the field, to provide a perspective on all of internet traffic. Sort of on the one hand, any kind of traffic, where is it going, what services, applications, and what's the rate of growth, and on the other hand, the pervasiveness of certain specific types of unwanted traffic, such as DDoS attacks. So they want to leverage their, I guess, approaching 3,000 deployments now, and have networks participate in this voluntarily to share anonymized data with Arbor. So, like I said, again, it's voluntarily participating ISPs. They share some anonymized data. Here you have, in this little diagram, toy diagram, 3 networks that have bought Arbor gear, perhaps Peakflow or something, and they send data then back to the mothership for Arbor to analyze, perhaps in an offline setting such as this, or in real time. These networks categorize themselves according to their type and their predominant geographic coverage. The data set, what we get is traffic in and out of a network, binned into 5-minute samples, the top protocols, ports, the ASNs where traffic is coming from and going to from the given network's perspective. And it's largely based on IP flow measurements as opposed to DPI. And it has, we've had this thing going for, I guess, 2 or 3 years, but for today, we're doing a 1-year measurement period. This slide is mainly to impress you. It's a little old. I guess the high-level message is that there are 65 networks in the Americas, 27 in Europe, Middle East, and Africa, and 6 in Asia. And at the end of our measurement period, we had a daily average of that exceeded 5 terabits per second of internet interdomain traffic in this data set. So we believe it's the largest of its kind. So now I've given you the sort of big lay of the land and sort of the measurement push. More specifically, repeating why might people care about the IPv6? Well, we're running out of addresses, or more specifically, the Iana and the RARs are running out of unallocated address space. The exact date when the internet will implode or explode, there's some uncertainty about. But I guess it's within the next few years, 18 months was mentioned. Luckily for all of us, IPv6 fixes all our ails. It has something on the order of 28 orders of magnitude more addresses, so that should be sufficient for a couple of years. And because we have this big problem and there is an available solution, there has been some government pressure in various parts of the world for us to make this transition. The OMB in the US mandated that IPv6 be available on routers. And in China, there's the Next Generation Internet Initiative, which, among other things, pushes for IPv6 adoption. Okay, so we have this problem, this solution, and people are pushing for us to make the transition. How's that going for you all? And ideally what we want, the direct measure, is an understanding of the amount of IPv6 traffic that is on the internet. Unfortunately, as people have mentioned today, and I can certainly attest to as an academic, it's really hard to get network operators to just share all their traffic data with you for various largely understandable reasons. Therefore, we have primarily indirect estimates of how much IPv6 traffic there is on the internet. So this is sort of the related work and was talked about earlier. 3% is the fraction of ASNs with IPv6 BGP announcements. That's a fairly small number, but it's larger than 1%, which is the fraction of Internet 2 sites with a passing IPv6 grade. A little disappointing. One might expect them to be ahead of the curve, or maybe they are. Even more disappointing is that 0.4% of the biggest websites, according to some methodology, are using IPv6. And finally, as you may predict, there's an even lower number, which is 0.2%, which is the IPv6 DNS queries as a fraction of the IPv4 DNS load. So we've got very small numbers here. There's an order of magnitude difference between the smallest and the largest, but they're all small. So our contribution is to provide another number to this, but one that is that directly states from our 5 terabits per second of average daily throughput traffic trace, the fraction of IPv6 in that trace was between 0.02 and 0.003%. So that I think you will agree is very small. So now I've told you the final number and the broad methodology. So a little more specifically, what is IPv6 internet traffic in our case? Well, I've told you what traffic is. That's largely from flow-based measurements. By internet, we mean interdomain. So this is traffic in our trace that crossed an AS boundary. And for IPv6, we wanted to cover both native and we wanted to look at the two primary forms of tunneled traffic. For the native, it requires, for us to be able to monitor it, the router has to have NetFlow v9. We have, of the two forms of tunneled, we have IPv4 protocol 41 tunneled traffic, and then Teredo traffic, which is tunneled over UDP port 3544. Here's another graph primarily meant to blow you away. This is the total traffic that we observed in our data set. So approaching 5 terabits per second. In this graph on the bottom, you have time, roughly end of July 2007 until end of July 2008. On the y-axis, you have throughput in terabits per second daily average. The bottom blue is the Americas. You have Europe, Middle East, and then Asia at the top. So it's a lot of traffic. Hopefully, a representative sample of internet traffic. So first, the denominator, the good news. IPv6 traffic is growing. On the bottom here, you have again time on the x-axis. The y-axis is megabits per second of IPv6 traffic. The blue is tunneled IPv4 protocol 41. The green is native. You're not blind. There is no green. The red is Teredo at the top, the little thin layer there. The good news is that we see, if you take the first quarter and the final quarter of our measurement period, we see a 30% increase. And it's approaching 150 megabits at the end of our measurement period. So that's the good news. 150 megabits, can sound like a kind of impressive number, but of course it's not all that impressive when compared to 5 terabits. And again, you have here in the graph time on the x-axis, and on the y-axis there's the percent bits per second of IPv6 as a function of the total traffic that we saw in our data set. This is not 0 to 4%. It is 0 to 4 when scaled by a factor of 10 to the negative 5. So that 3 there is 3 thousandths of 1% IPv6 traffic. I think you will agree that is very small. And the other thing is, while there is increase in our data set of the amount of IPv6 traffic that we observed, it is in fact growing slightly slower than overall internet traffic. So when compared to overall traffic, it's actually stagnant. And that pretty much are the results for my talk. We went looking in our giant data set for IPv6 traffic, and we didn't really find much. But we have this. We released a tech report, a month or two ago, and this slide isn't. I didn't even make this graph. This was generously donated by the kind folks at Hurricane Electric. It just demonstrates that our report had an immediate, profound impact on industry. On the x-axis of this graph, you have time. On the y-axis, you have tunnel broker account signups for Hurricane Electric. So right when we released our report, there was a doubling in the amount of people signing up. The good news, I guess. So potential objections to the methodology. So the one that we heard a couple of times is that we weren't monitoring your network. I guess the corporate perspective there is that's super. Please call Arbor today, and they would be happy to sell you boxes and include you in the measurement study. The slightly more scientific response is that at 5 terabits per second, it's certainly the largest study today that I'm aware of, and hopefully you believe that it's representative. There is a North American, also on the sort of selection of networks, there's a North American European bias. There was about a 1 terabits per second at the end of traffic from Asia, but yes, there was a North American European bias. We also focused on interdomain traffic. Some people have been saying that there is more IPv6 intradomain. That is something we have access to that data for the networks in question. So we hope to look at that in future work. And also for future work, again, this data set is flow-based primarily. We also hope to do a measurement study based on DPI data. Perhaps IPv6 traffic is hiding in other ports. Then final slide of the objections. It's possible we're undercounting native IPv6 traffic. Like I said, for us to measure it, monitor it, the router needs to have v9, and it seems that v5 is the flavor of choice. On the one hand, I can punt on this and say, hey, that's not my fault. The router, the network operators need to make this transition. The other point is that, someone somewhere made the determination that it wasn't necessary to do this upgrade to perform this monitoring. And so one can read things into that. It's also possible that we're undercounting Teredo traffic because my understanding of the protocol is that the realizing servers listen on 3544, but subsequent data traffic need not. We looked into this a little further. Scott looked into it a little further and found that, there are only 2 of our 100 deployments that saw more than occasional few kilobits per second of traffic on this port. So there wasn't a lot of relay and server traffic. So if we're undercounting it, we're probably not undercounting it by much. And as you may recall, the Teredo was just a very thin line up there. So even if you multiply it by a factor of 10, it's not going to change the fact that 0.003% of traffic is IPv6 in our data set. Okay, so to conclude quickly, we took a look in our data set. We found some IPv6 traffic, very little. There is some growth, but not compared to overall internet traffic. So largely negative news, I suppose. My talk is mainly a measurement talk, deliberately dry and boring, but perhaps, and other people have much more eloquently argued for why there has been this sort of lack of a transition. But very quickly, from a lot of networks perspective, transitioning to IPv6 represents probably a net outflux of money, at least for now. There's a cost associated with the hardware-software transition upgrades, but not clear that there's any added revenue. It's also a chicken and egg problem, like people have pointed out. There are no users, so content providers don't feel a need to upgrade, and there's no content, so users don't feel a need to upgrade. We haven't had that killer IPv6 app, except for the dancing turtle. And then it's perhaps understandable, a lot of people have the opinion, at least from my perspective right now, IPv4 is working well. Why should I mess with my network? So then I'm going to end, let you go to lunch early, and I will be happy to take any questions. Thank you.
Jay Hennigan with Impulse Internet Services in Santa Barbara. As far as IPv6 content, it seems to me that one of the things that is preventing this is the large number of broken IPv6 implementations out in customer space. And that if, for example, I know that Google has IPv6.google.com, which works very well. But my understanding is that if a number of websites, if they were to put a quad A record for example, www.google.com, that people who are running an IPv6 stack that don't have IPv6 connectivity would break. And so the problem is that I don't know how to resolve that, but that to me seems to be a major stumbling block for getting IPv6 content out there. It has to be made somehow transparent to the users so that they essentially go to the same site and it just works. So I think that the customer space needs to have some major upgrades so that if they get a quad A record and they don't have IPv6 connectivity, that it will relatively quickly and seamlessly fall back to v4.
I completely agree, and I suspect it's probably one of several major stumbling blocks. Please.
Could you please go back to your Teredo slide?
Stop me.
Doesn't matter. You're counting the traffic on the well-known UDP port number.
Yes.
So what you're doing is you are counting the signaling traffic to Teredo. You are not counting the data traffic.
Right.
So the data traffic is several orders of magnitude larger than the signaling traffic. So
right.
what you are measuring is actually irrelevant to Teredo.
Right. So
that's actually where the action is right now. There are some peer-to-peer applications that are in that space, that you are not counting.
Right, so you agree that the relays and servers have to, they synchronize on this port.
That's only the first packet.
Right. So even if we multiply that by 2 orders of magnitude.
Well, it doesn't mean anything. The signal and the data are completely unrelated.
Okay.
So if you do not measure the data path, you do not measure anything.
Okay. So that's the need for DPI measurements, certainly. I guess I would, sure, the DPI measurements are necessary.
Yes.
Go ahead.
I'm Martin Leader from Hurricane. Could you go to the penultimate slide for your conclusions?
Certainly.
And stop. I wanted to know what packet filtering you used in order to understand the money, high cost, no added revenue part. Where were you filtering to understand the revenue aspect of V6?
I mean, this is, I don't understand it. There was no, I don't understand the question.
Okay, I just wondered why there was revenue in that, because nothing from what you said had anything to do with revenue up until this point. Okay, traffic on AMSICs, 0.1% at the moment, sitting as V6.
Mm-hmm.
Major difference from what you're seeing on your numbers. You're down in the
What transits?
So that's just on the AMSICs exchange in Amsterdam. Second question is, on all of the networks that you measured for this data,
right,
did you have any of the major V6 backbones within your measuring set?
Any, I can't answer that off the top of my head. I also, I mean, there are other measurements out there, and I don't know their methodology when compared to ours, so it's impossible for me to answer.
Okay, so does that mean that there's a measure of what's your confidence factor on this number?
I am completely confident that this answer represents the fraction of IPv6 as in our data set of a 5 terabits per second data set.
Okay.
Patrick Gilmore,
please.
Partner, the 400 megs on AM6 is actually almost all news peering from a single provider. I don't think it's representative of the whole internet, since they only offer it over the AM6. That's the only place you can get it. And if you turn that news peering off, it drops by at least 2 orders of magnitude. So the AM6 thing is a little off. That doesn't mean that there's not more traffic in general. I'm just saying that AM6 is a bad data point to say that this data set presented in the slides is wrong.
Thank you.
Randy Bush, IIJ. We're arguing over how powerful a microscope you need to see the V6 traffic. All of the microscopes are pretty broken. I do internet measurement. It sucks when some serious computer scientists are measuring your product as a behavioral phenomenon. You are in trouble. And it's a turtle and egg problem, not a chicken and egg problem.
Jeff Houston, I must admit, this whole issue of exactly what you're measuring and what does it mean really becomes a problem. I looked at this same thing about traffic, and the problem with a lot of the traffic we actually see on the network is heavy tail distribution. There's an astonishing amount of large traffic flows where the volume is high but the number is low, and an awful lot of folk with very short traffic flows where the volume is extremely low per flow, right?
Mm-hmm.
So what do you mean when you say, I looked at traffic, versus what does it mean to say an industry is making its steps towards migration? And part of the reason, I suppose, why I, in looking at what was happening at a web server, really didn't bother about trying to look really hard about the amount of traffic, was that I'm not sure I understood what I was measuring when I was getting my microscope out to look at the packets. It just didn't seem to make much sense in terms of what's the real question I'm trying to answer.
So absolutely, and I mean, I didn't mean if it was, I didn't mean at all to say that the related work was not very useful, and I think each of the different metrics that you choose to measure will have weaknesses, and are useful for some things.
Normally, just to wrap this, you've looked at 5 months.
What's that?
You've looked at 5 months here, September through to December.
It's a year.
So what was it like a year before, and the year before, and the year after? Some ways, when you actually don't know what you're measuring in reality, as long as you keep on doing it, the comparison between what happened before and what happens in the future then becomes the interesting bit. It's the first order differential that then becomes, you know, the actual metric you're after. That seems amazingly flat, but that's an amazingly short sample.
A year?
In this kind of world, yes, we move very slowly, evidently.
Please.
Hi, Lisa from Dnssec. I just want to add to the previous discussion that we measure native IP6 traffic based on SFlow data we have. And it was true indeed that it was in the beginning caused by basically one provider who enabled new services over P6. And that is not true anymore, at least from what I can see in the growth that happened. I mean, we do about 600-800 megs, I believe. And 200 of them were this first provider who enabled it half a year ago. Thanks.
Okay, is that all questions? Okay, thank you, Hakon. Oh, wait a minute, one more from Randy.
Talk is cheap. How many providers here, Randy Bush, IHS, sorry. How many providers here have public SMTP servers that are accessible over IPv6? Web servers, DNS servers. Okay, could some researcher actually take this measurement, not by raised hands, by actually doing something like taking the NANOG list, going to their site, and find out, through all this BS, are we as a community actually deploying IPv6? Are there going to be more turtles than eggs? You know?
Okay, thank you.
Thank you.
Well, we're ahead, so we have one more question
So,
from
John
John.
Curran, I'll put my Aaron hat on, make it really clear, Chairman of Aaron. We don't have to deploy IPv6. If you don't need more addresses, when the central RIRs run out, when the central red pool runs out, and then the RIRs run out, there may be some reclaimed. You're all going to mine your own infrastructure. You may go back to customers and say, hey, I really want the other half back because you're not routing it and I need it. There'll be some soft places you can recover. But you don't need to deploy V6 unless you're relying on the fact that you continually need new addresses to connect new customers. That doesn't apply to everyone in the room, but it does apply to some folks, and they're aggressively deploying V6.
Okay, well, before we quit for lunch, I have one thing to remind you of, which is to please vote, if you haven't already done so, in the steering committee elections. You have 28 minutes before the voting closes at 1 p.m., so it'd be nice to see more votes. And, of course, don't forget to complete the survey before you leave. There's plenty of them lying around, or you can do it online. Okay, it's lunch on your own now. We restart at 2:30.
I am sending out acceptances